Dear colleagues, let's continue our workshop. And I'd like you to remind you that let's keep deal with our schedule. Yes, and our session is devoted to system of information security. Yeah, and let's make presentation 10-15 minutes, please. So, are you ready? So the first presenter must be someone from the team of Olha Kovalchuk, Sergey Banach, Mikhailo Kosinchuk, Nadia Moskalyuk, and Valery Kanyuka, who will be presented from your team.
I'm ready.
Okay, Olha, please.
Thank you. I can't, sorry.
Tatiana, maybe you haven't shared possibility to share the screen of participants.
Yes.
Oh, yes, I can.
Okay.
Yes. Dear participant of the conference, I appreciate this great chance to present our scientific result of the research associative rule mining for the assessment of the risk of recidivism. Let's get started. Solving crimes is a complex task and requires significant resources and expertise. Data mining models can provide effective solutions for solving complex, no-standard problems of crime detection. AI algorithms are increasingly used in predictive justice to support this judicial decision-making, in particular the qualification of crimes and the relevance to the criminal process. Traditionally, the task of law enforcement agencies is to arrest criminals already after committing crimes. However, data mining and artificial intelligence tools create effective solution for collecting and interpreting connections and patterns in data from various open closed sources, such as crime records, geospatial images, social network information, news feeds, etc. The aim of our research is to create an associative rule mining model which, based on known individual characteristics of convicts, historical crime data of convicted, reveals implicit interesting connections that are sufficient reason for the repeated offenses. For our applied research, we use one of the common methods of extracting new knowledge, associative rule algorithm. The task of associative rules is find patterns in the flow of data. Association occurs when several events are connecting to each other. Hidden connections are revealed in seemingly unrelated data. We applied the RapidMiner tools to the FP growth algorithm and compiled an associative rule mining model. Database was formed on the basis of crime records of 13,010 prisoners serving sentences in penitentiary institution of Ukraine. To identify associative rule between historical crime information of convicted and repeated offenses, a dataset was used which contain the following attributes: availability of recidivism, sex, marital status, education, place of residence, type of employment, availability of early dismissals, motivation for dismissals, actual age, age at the time of the first actual degree of punishment, age at the time of the first suspended sentences, number of real convictions, and number of suspended convictions. To implement associative rule mining algorithm, a process consisting of the following operators is compiled. Association rule make it possible to find non-obvious patterns between relating events and discover all such relationship between elements from huge databases. As a result of the compiled associative rule mining models, the frequent item sets and the association rules were obtained. The developed data mining model give reasons to claim that in the analyzed record crimes, that the most frequent individual characteristic among those sentences to real conviction is recidivism. Therefore, a significant share of prisoners' information about which is stored in the study dataset already had previous convictions. The most frequent combination of investigated features are recidivism, early recidivism, and recidivism, suspended convictions. This indicates that the majority of prisoners who committed repeated crimes offenses had early dismissals and suspended convictions in the past. Association number 6 20 and 37 cannot be attributed to associative rules. A science lift equals 1. It means that relation between antecedent and consequent is absent. All other identifying associative rules are strong as they have higher support and higher confidence. They demonstrate a strong positive correlation in the dataset and often occur when applied. From obtained result, it can be concluded that the main signs that provoke the risk of recidivism are probation and suspended convictions. Frequent items that were identified and 43 associative rules were generated, which can explain non-obvious connection between crime record information of convicted and repeated crimes. It was established that the main signs that provoke risk of recidivism are probation and suspended convictions. Modern prisons protect society from dangerous criminals, but they do not make them law-abiding. The leniency of the justice system, in particular the application of suspended conviction and the use of probation, gives the accused more hope impunity than a chance for correction. In general, machine learning methods and artificial intelligence systems will probably not become a panacea for the criminal justice system, but them can provide significant advantages in choosing an effective strategy for conducting criminal proceedings and maybe optimizing the activities of justice authorities. Thank you for your attention. Now I'm ready to reply to your questions.
Thank you, Olha. Dear colleagues, any questions?
Yeah, I have one question.
Please, Eugene.
Did you use the a priori method?
A priori, yes.
Then
I have one more question. Can I?
Yes, Taras, please.
Okay, I just have one simple question. What is the particular value of your research?
Our research is carried out as a part of development of unifying concept of information and analytics support for the criminal justice system of Ukraine. In previous studies, we use the method of binary logistic regression to predict the probability of convicted criminal recidivism in the future. And we create the scoring model for assessing the risk of recidivism by criminals based on individual statistical and dynamical data of convictees. The obtained result can be used to determine the most significant factors influencing the propensity of convicts to reoffen and to identify prisoners with higher recidivism. For example, when establishing the possibility of the suspended sentences, bail or parole.
Thank you.
Thank you, Olha. Colleagues, any more questions? No, thank you. So let's move on. And the next presentation, I suppose there was a small exchange in our schedule. And Taras, are you ready?
Sorry, you hear me?
Yes.
I guess it's the second research should be Solomia Yatsky, maybe.
Okay. Please. Maybe.
Yeah,
Excuse me, Salome Yatsky. Excuse me. Are you ready?
yeah, sure. Good morning. Let me share my screen.
Yes, please, Salome. You have up to 15 minutes.
Okay, thank you. Good morning, dear participants. Let me introduce myself. My name is Solomia Yatsky, and I'm a PhD student at West Ukrainian National University. The topic of my presentation is the method of chain execution of the basis operation of the Rabin crypto system. I'd like to start with the overview of Rabin crypto system. The Rabin crypto system is a family of public key encryption schemes based on a trapdoor function whose security, like that of RSA, is related to the difficulty of integer factorization. The Rabin trapdoor function has the advantage that inventing it has been mathematically proven to be as hard as factoring integers, while there is no such proof known for the RSA trapdoor function. The Rabin trapdoor function was first published as part of Rabin signature scheme in the 1978 by Michael O. Rabin. The Rabin signature scheme was the first digital signature scheme where fortune signature could be proven to be as hard as factoring. Like all other asymmetric crypto systems, the Rabin system uses a key pair, a public key for encryption and private key for decryption. The public key is published to anyone to use, while the private key remains known only to the recipient of the message. Let's move on to the next slide and consider key generation. To generate keys in the Rabin crypto system, two large prime numbers P and Q are chosen, which act as a secret key. Their product M equals P multiplied by Q is a public key. The encryption of the plain text block V, which must be maximal less than M, occurs according to the formula that equals V to power 2 by modulo M. Decryption is much more complicated process and it takes place in several stages. All the formulas used for decryption are displayed here on the slide. Moving on to the next part, we will talk about Rabin encryption scheme. So basically the figure 1 shows the Rabin encryption scheme. As you can see, the complete cycle of Rabin crypto system involves the execution of Euclidean algorithm for 2 numbers, private keys, and their multiplication. As was mentioned before, we use the Euclidean algorithm in the proposed system. The mathematical basis for that is shown on this slide. The mathematical notation of Euclidean algorithm looks like this. For any x greater than y, which at the same time equals R1, where x and y are integers, the system of equations is fulfilled. Let's consider the proposed model in details. An algorithm for the simultaneous execution of the Euclidean algorithm and the multiplication in Rabin crypto system is shown on this slide. It's proposed to use the intermediate and final results of the Euclidean algorithm in the multiplication according to the formula presented on the slide here. Although the method involves the performance of a larger number of arithmetic operations, they will be performed on numbers of smaller digits. Having a table of squares in the computer's memory is an essential step to increase performance, although this leads to an increase in the usage of computer system resources. So let's move on to the obtained results. The time of simultaneous execution of the Euclidean algorithm and multiplication of numbers by classical T1 and proposed T2 methods for B equals 2, 3, and so on up to 70, if A equals 71, is shown in this table. The corresponding graphic representation of these calculations will be presented on the next slide. Here you can see the corresponding graphical representation of the result for the basic method T1 and T1 average, which is marked by a dashed line, and for the proposed method T2 and T2 average, which is a solid line. As you can see, the graphs have an oscillating character, which is explained by the different number of steps in the Euclidean algorithm for different numbers. In 60 cases out of 69, which is 87%, calculations using the proposed method were performed faster. In 7 cases slower, and in 2 cases, the execution time for both methods was the same. The average time values are respectively T1 average is about 0.040, and for T2 average is about 0.0.2 seconds, which is also presented on the graph. Therefore, the speed increased by average of 1.43 times. The calculations of the time spent when the prime number's bit size is in the range from 67 to 127 bits, and number B is in the range from 2 to A-1, are presented in the table 2. And here is the graphical representation of these results. Table 3 presents the average time of simultaneous execution of the Euclidean algorithm and multiplication by the classical T5 and proposed T6 methods in the case when the bit size of n prime numbers A is in the range from 7 to 16 bits. And again, here is the graphical representation in the logarithm scale. On this slide, you can see the graphical dependence of the average time of simultaneous execution of the Euclidean algorithm and multiplication by classical T7 and proposed T8 methods on the number of digits of A. The average time of simultaneous execution of the Euclidean algorithm and multiplication by the classical and proposed methods in the case one-digit number of n prime numbers A, the parameter A was assigned to the value of the smallest prime number that exceeded 2 multiplied by n, is in the range from 16 to 44 bits, and as it can be seen from the figure that the graphs are placed almost parallel. So with the large bits, when n is greater or equal 40, the intensity of T8 growth decreases. All calculations were repeated multiple times to eliminate random effects on runtime. In conclusion, this work deals with an experimental study of the time of simultaneous execution of the Euclidean algorithm and multiplication of two multi-bit numbers by classical and proposed methods. The proposed method stipulates the use of intermediate results of the Euclidean algorithm and the table of squares available in the computer's memory. The research was conducted on numbers of different digits. It's shown that for the vast majority of considered numbers, the proposed method requires less time to perform arithmetic operations, and the average time of simultaneous execution of the Euclidean algorithm and multiplication decreased by approximately 1.43 times. Thank you for attention.
Thank you, Solomia. And dear colleagues, any questions?
What are the advantages of your method?
So basically, it allows improving the time of performing those calculations. As it was pointed on the graphs and in the results, we achieved 1.43 better execution time compared to the previous methods.
Thank you.
Thank you.
Solomia, can you say what the main limitations of your approach?
Yeah, sure. So basically, it works the same way when we have less bit numbers, but with increasing bit numbers, we see a great difference in the results, and it's really more important. We see better improvement of the results with huge numbers.
Thank you. And what is your future work in this case?
We will work on improving this method for like the areas where it doesn't show greater results for now, and basically we'll consider using other methods as well.
Okay, thank you. So, colleagues, any more questions? No?
I have
Thank
one.
you.
I have one. Sorry.
Yes, please.
If I can. Okay. Solomia, I just have one question. Okay, if you know the time to perform the same operation by the computer is not the same, as it depends on many factors that are difficult to take into account. The main question, how you will prove the validity of your results?
Sure, thank you for your question. We considered this possibility that the results may be affected by multiple factors, and basically that's why we performed and repeated all operations 5,000 times, and we took average number as a result and considered it for the research.
Thank you.
Thank you.
Thank you.
So, okay, let's move on. The next presenter is someone from the team: Denis Lubinetsky, Antonina Kashtelyan, Tomasz Sochor, Andrei Selsky, and Alexander Clay. Who will be presenter?
Me, of course, me.
Okay, Denis, please.
Denis.
You have up to 15 minutes. Don't forget it. Okay?
Sharing. Do you see? Okay.
Yes.
Hello, dear audience. My name is Denis Lubinetsky, and today I wanna show you a presentation on the topic distributed system for prediction malicious activity in computer networks. Objective of research, the purpose of the study is to design and implement a distributed system from predicting malicious activity by using neural network and improved method of self-organized algorithm. In addition, such a system will use the components distributed among several computers in networks, which will allow to work even after the failure of some nodes. Distributed self-organized system. an anomaly detection system in network should have a distributed architecture, because in this case it will be able to take advantage of attracting more of computing power due to the pooling of computing resource of all computing power of the system where its components are installed, compared to malicious manifestations that may come to be carried out in one or more nodes in network. Self-organizing will give an opportunity to change its internal structure and its function to respond to external circumstances. Proposed systems. The proposed system will work on the basis of instruction detection system. Such a system will be based on a neural network that will be trained using test data and modified for getting garbage, self-organizing incremental neural network. Features of SOAN. SOAN is a neural network with two layers. The first layer is used to determine the topological structure of a cluster, and the second to determine the number of clusters and identify prototype nodes from them. First layer, the network is trained, and then using the data obtained during the training of the first layer, the second layer of network is trained. SOAN offers unsupervised training for an incremental clustering method with relatively high processing speed at low computational cost. In addition, the complexity and size in the SOAN network is controlled and stabilized through garbage or discovery of unnecessary neurons or nodes. The technical collector of the minds of where of node determines when and after which node of the period will be removed. But if they are not updated at specified time, they are simply deleted. This probably makes it attractive for the dynamics of any environment where continuous learning is required. From a feature from the slide is online training of lifetime algorithm, classification without prior knowledge of input data, separation of data with a fuzzy border and revealing the basic structure of clusters, adaptive learns data by itself, solves the problem of processing large amounts of data, robustness of noise, and fast processing and operations with system. Training in SOAN means adaptation of the topology map. Nodes can move, join with the other nodes, remain single or removed, and the edges between nodes can be created or deleted. FG SOAN algorithm, as I say earlier, for getting garbage, self-organizing incremental neural network. In the SOAN node and edge, removal is defined by two parameters that need to be optimized for each existing programs using cross-validation or similar resampling approaches. FG-SOAN overcomes this drawback by treating nodes and edge removal as an integral part of the learning process. Three concepts were formulated to the form garbage forgetting, downtime, reliability, and utility. FG-SOAN function are similar to function SOAN, but with a little difference. First one is the distance function, the same. Compute the fractional distance between two arrays of values, finding winner nodes and edges. Compute similarly thresholds function, adding nodes, merge winner nodes function. A unique function that I add is a linking function. that tries to link nodes that are not likely to represent signal that are represent signal but not noise. Linking depends on the trustworthiness of a node, and edge nodes deletion group signals that we determined as a class labels. System information flows based on FGSON. Figure shows that how information flows are processed in the system, where traffic checked for classification in the system. The system starts with the fact that the incoming traffic collected by system during the work cycle in the feed to the preprocessing model. Is system model can capture and process incoming traffic in real time. The defined and identified connections are processed to extract and further use the function. This function will be the input vector or detection mechanism. That have FGSON algorithm. The information is then fed to the malicious activity detection engine, which after processing transmits the traffic information to the data validation engine model. The validation model determines how the system improved and improved by confirming the expected label. In this stage, the traffic is divided into malicious or good traffic. After confirming that traffic is normal, he is transferred to the users for further work. However, if system confirms that malicious traffic has been detected, the data validation model will forward forecast to the update model and the traffic from the dataset delete traffic from a dataset. The system update model operates in two phases. The active phase and update phase. The active phase model makes decision using the data in process at the time. In the system update phase, the model updating that data with valid predictions that will improve its capabilities in the future. Experiments results. The training of the system begins when the study is 126,000 traffic instances of the NSL KDD dataset. Due to the fact that the input data set includes large samples of data, 5 binary classes were created. The comparison took place using the test sample test. Data represents over a period of 12 updates. First, using the test sample test, both networks were trained, a network based on a SOAN algorithm and network based of FGSOAN algorithm. Then was testing to identify instruction using both systems. Then on the basis of the noisy data, the system were alternately retrained. On this slide, we can see the comparison of system-based of algorithm FGSOAN and SOAN by instruction detection capability. It should be noticed that after the initial training for each round of renewal subset is checked of the trained, FGSOAN and only SOAN forecast return to the system. For visualization, the data received after the training were present on the linear graph, which is shown on the slide. The blue color represents the percentage value of the system results with learned FGSOAN algorithm, and red is SOAN algorithm. This identifier shows that accuracy and capability. This is graph of capability. Next is accuracy. Is higher. The FGSOAN algorithm is higher result as SOAN algorithm. The quality of instruction detection is improved with each new phase, which confirms the efficiency of the proposed algorithm modification. Future work This algorithm was first invented in Japan by Osamu Hasegawa. Today, after many modifications, it's used only for processing traffic data, but also for personal human needs. An example would be the use to predict traffic or the use to predict human health for medical application. Improvements in the accuracy of prediction outcomes for a self-organizing system is the future will provide more opportunities for prediction the data of any area of human activity, as we say at road mapping, health, calendar prediction. Conclusion. The structure of the developed system and its result shows that the proposal is confidently adapted with the nature of dynamic network data profile. It will perform the function of the distributed algorithm in the system. The system used fewer resource, runs faster, and has a higher detection level than a teacher training or a simple SOIN. Analysis of the proposed FG-SOIN algorithm, which will be used in the distributed instruction detection system, showed that efficiency of each sequence phase of updating and developing the system improvement more than 3% will give a good result on huge volume of data. If we provide the system many unsuccessful prediction, we are not only achieve incremental learning with great and promising accuracy, but also create an efficient, effective structure. It will be simply not be necessary to add a full data set to the system. Thanks for your attention. If you have any question, you can ask them.
Okay, Denis, thank you a lot. Okay, colleagues, any questions, please?
Why didn't you choose the ART self-organizing neural network?
For my opinion, this system can be our contemporary needs to solve a lot of problems that used a lot of problem, and we must use artificial intelligence and neural network for our activity. Self-organizing system is SOIN. It's a good, simple, good sample for us to find a new way, and teaching and learning for learning system in for our future. So I wanna say that SOIN is a good choice for self-organizing algorithm learning, and I used them for his for modified and implement to the instruction detection system, because we need to predict big volume data, and using different solution for this moment.
Thank you.
Thank you for your question, and thank you for your answer, Denis. Any questions, please? Okay, and one question, Denis, what is the bottleneck of your approach? I mean, maybe you have some restrictions of your approach, limitations, and so on.
One limitation, I have one of them, they need a good computing system, because we need to processing a lot of data, because we need processing a lot of data.
Thank you.
Information.
Okay, I see. Thank you. So, colleagues, let's move on. And the next report, data collection system from the RPL routing protocol for detecting distributed denial of service attacks in the IoT networks. Who will be presenter?
Hello, I will be.
Okay, Andrei, please.
One moment.
You have 10-15 minutes, please.
Okay, thanks. Do you see my screen? Yes. Is it good?
Yes, everything is okay, please.
Okay, thank you. Hello, dear present. I'm going to present you a report on the topic a data collection system from the RPL routing protocol for detection distributed denial of service attack in IoT network. This report is presented by Andrei Nichiporuk, Associate Professor of Computer Engineering and Information System Department. Today, the concept of Internet of Things demonstrates a steady trend towards development in the field of information technology, primarily due to the spread of wireless sensor network, the acceleration of the transition to IP version 6 addressing to use the cloud computing and the development of machine learning techniques and so on. However, the heterogeneity of environment and the wireless way data exchange make IoT networks potential targets for attackers. Among of main security threats of IoT networks are denial of service attacks. It's shortly DOS or DDoS. This type of attack leads to loss of access to the device or the resource it offers. However, today, traditional denial of service attack detection approaches do not meet current security requirements. In order to increase the reliability of and accuracy of detection of DDoS attacks, we propose a system which consists of three main modules. And the principal sham of this system is presented on this slide. So in general, this system contains three modules. It's data gathering module, DGM, classification module, and mitigation and detection module. The DGM or data gathering module, it can be considered as an interface module, as it is involved in two phases of system operation. We name it this phase pre-training and post-training. Another two module, it's CM and MDM, are part of post-training phase and are responsible for detecting attacks and forming countermeasures. It's the first. Let's consider in some more details. Data gathering module DGM and before detecting any malicious activity, it is necessary to obtain features from the network that would allow to identify the occurrence of any malice. For this purpose, the system uses data gathering modules. In this system, we use features from three network layer. It's a physical network and application levels, and the features which we used in our study are presented on this in this table. And I shortly say it's in general it's RSSI. It's received signal strength indicator, rank of node, and additional information about a building DUDAC tree. It's DO message and this message. Next, module in our system, it's a classification module and mitigation module. And in general, classification model, it's check the presence of anomaly activity, and mitigation and detection model, it's make model that main function of which it's make countermeasure for 3D. So as I said previously, our system have two phases, and post pre-training and post-training phase. The function of in pre-training phase, the machine learning model is trained and tested on the basis of data collected by the DGM model. In this work, we studied two machine learning algorithms that will be investigate and test in data collected by the DGM model. The post-training phase is responsible for processing data and performing real-time activities. The operation of the data collection system from RFPL routing protocol involves several stages in post-training phase. It's the first one, aggregation of traffic. In this step, we collect data from several sniffers which is operated in RPL network. And we have quit it and select we remove duplication of data in our queue. Next, it's a feature, second stage, it's a feature extraction. We select a time window and extract a feature by this period. Next, it's a classification of attack, and the last one, it's a generation of result. It's this stage involving generate the UDP packet that will be sent to all of nodes, which the main purpose of which is to notification another nodes about presented malicious activity. Next, it's an experimental part. We make some experiments based on Ubuntu operation system and Koja simulator. During modeling network, we use type of mode Zolertia Z1. Next, to obtain test data, a homogeneous network consisting of two types of nodes was deployed. In general, we have sync node and it's simple or client nodes. The parameter of our test bed is presented on this type on this table. To test malicious activity, we use we investigate black hole attack. In simple word, it's DDoS attack in which malicious nodes drops the packet. So if you see in this picture, it's a schematic representation. It's 5 packet, yeah, and if such as we consider mesh network, which that involving transition from source to destination by the intermediate nodes, and you see that some in some point which is present compromised node, some packet will be dropped, and the final resulting message do not come to the destination. Next, we use in this environment we simulate this network, and we obtain some data. We obtain the features vector. It's, you see the total number in total number of this vector in table. That this features vector represented classes such as our classification system. It's only operate plus, yeah, it's malicious and normal. Next, also we divide our training data set in in 2 parts. It's a test and learning and test data set, and we investigate our approach by checking the accuracy of our overall our system, and as a metric to calculate the efficiency, we use the standard in machine learning metrics accuracy, which means you see the equation in this slide. And the result of based on the result of conducted experiment, we can say that both to machine learning algorithm, which trained in our data, had accuracy more than 85%. But better results were obtained in SVM support vector machine algorithm, and you see the numbers of result of our experiments in this slide. Thank you for your attention.
Thank you, Andrei. Dear colleagues, do you have any questions, please? Yes, Eugene.
Which support vector machine did you use? For example, C SVM, new SVM, one class SVM.
We use SVM algorithm as in Weka software, and our classification as for multi-layer perceptron, as for support vector machine, we have 2 classes only. We do not consider as subclasses of malicious activity. We just classify by 2 classes, or normal or malicious activity. That's all. It's our future work to introduce more DDoS attacks, such as this is very spread type of malicious activity in network and in IoT network, and we will work deeper to distinguish this, not just say this is traffic is malicious or this is not, it's a malicious activity, but say what exactly malicious activity.
Thank you. And other question, please detail the multi-agents.
You mean, do we consider multi-agent technology?
Slide 2 or 3.
This is second. You made general sham. Maybe you say stop. I scroll down. I don't understand what exactly slide open. Do you hear me?
Yes.
Yes.
Okay. I do not hear. I do not understand what exactly slide open.
Repeat last question, please.
Thank you. Thank you.
Okay.
Okay.
Thank you, Andrei.
Thank you.
Okay, let's move on. The next presentation is devoted to algorithms and data encoding decoding devices based on two-dimensional modular correction codes. Who will be speaker? Taras, are you here?
Yes, I'm here. Sorry.
Okay.
Hello, my name is. Okay, shall I start?
Yes,
Okay.
please.
Hello, my name is Taras, and I would like to represent to you algorithm and data encoding decoding devices based on two-dimensional modular correction codes. So, with the constant development and wide implementation of wireless technologies, improving the reliability of data transmission in wireless sensor networks remains an important and urgent task. The main mechanism for improving the reliability of data transmission in wireless sensor networks in the use of error control schemes. Their task is to ensure reliable communication in a wireless channel in which errors occur due to interference, fading, and loss of bit synchronization. This leads to channel errors that affect the integrity of the packets forming the sensor node. The low power of the wireless sensor networks transmitters, which is connected with the use of autonomous power, also leads to an increase in errors. Thus, in addition to methods of improving reliability at the physical level, which guarantees the reliability of transmission at the bit level, wireless sensor network also requires the application of errors control schemes at the channel level to ensure reliability at the level of packet transmission. Modular corrective codes developed belong to symbols codes characterized by low redundancy and allow efficient detection and correction of single symbols errors. In modular correction codes, the data packet in the binary code to be transmitted is divided into k blocks of the same length, tetrads or bytes. The formation of the two-dimensional modular code you can see at this slide. So error detection is based on syndrome analysis, which is calculated as the difference between check symbols calculated in the encoder and decoder. At this slide, we consider that the modular code can correct two errors. if the location is known. Then the maximum length of the error packet you can see at this slide on the left figure. However, on the other side, this code will not be able to correct a package of errors of 6 characters, which are located at the intersection of 3 rows and 3 columns. On this slide, you can see a block diagram of the algorithm for error package detection and correction. On this slide, we can see an example of 2-dimensional code based on a modular correction code. And consider the error correction algorithm for the maximum number of the destroyed symbols. We can see at this slide that we have some destroyed symbols on first 2 rows and the 4th column. The values of the syndromes calculated by rows and columns of the data matrix. Since the syndromes are not equal to 0, the distorted symbols are in all rows and columns of the data matrix. The error detection and correction algorithm consists of the following steps. Like we check whether there are lines with 1 error. To do this, we successfully solve this equation for each line. The solution we can see at this slide on the table. As we can see from this table, the solution found in integers in the given range from 0 to 15 and indicate that the symbols in X4 is destroyed in line 3 to 8. After analyzing this table, show us that there are errors in all columns, but only in 2 rows. That is, all symbols in the first and the second line are destroyed. On this slide, I show you the structure of coder, where the message with the case symbols is received at the encoder input. The coder calculates the check symbol and writes the message with the check symbol to the buffer. And the process is repeated until key messages are received, and a data array is formed from the received messages, from which verification symbols are calculated by the column of the array. At this slide, we can see the structure of the decoder, and this decoder calculates check symbols on the received data and compares them with those that were calculated by the encoder and sent. The correct errors in the data packet, a table of syndromes is formed in the decoder by rows and columns. A 2-dimensional approach to error correction based on modular correction codes is proposed, which provided effective correction of error packets. It's characterized by a high correction ability and low complexity of decoding algorithm implementation, and accordingly can be applied to increase the reliability of data transmission in wireless sensor networks. An algorithm for detecting and correction error packets based on modular corrective codes and 2-dimensional scheme has been developed. This algorithm provided detection and correction of packets with the k-length of errors that are in 1 row or column of the data matrix of size k on k or 2 on k, errors that are in 2 rows or 2 columns of the data matrix. Moreover, the algorithm provides correction of the maximum length of error packages that you see that calculated by this formula at speed of code error equal 0.67. if the destroyed characters are in 2 rows and 1 column, or in 2 columns and 1 row. A structure was developed and an encoder for calculating check symbols and forming data packet based on 2-dimensional modular correction codes was developed and implemented on an FPGA. Thank you for your attention.
Thank you. Taras, okay, colleagues, do you have any questions?
Were you
Yes, please.
planning to use a transformer neural network? Decoder, encoder.
Sorry, could you repeat your question, because I have some problem with the internet connection.
Were you planning to use a transformer neural network for encoder decoder?
Maybe in the future, yes, we have some plans to do this, but nowadays the neural networks just growing up and rising day by day, and it would be better to use the neural network for implementing this structure of coder and decoder.
Thank you.
Thanks.
Okay, any more questions? No, so let's move on. Okay, thank you, Taras.
Thank you.
So the next, and it's, I suppose, the last for today, speaker. And the presentation will be devoted to hardware and software part of a distributed decentralized systems detections malicious software. Who will be presenter? Oleg, Mykola, Yuri, Antonina,
Yes,
Bogdan?
I'm prepared. I'm share my ecran.
Okay, please, Mykola.
You see my ecran?
Yeah. Yeah, you
Okay,
have.
let's go. Hello, dear
Yeah, please.
class. I'm going to present you a hardware support for a decentralized distributed malware detection system by a microcontroller-based USB computer. This report presented by Mykola Stetsuk. Modern malware is quite sophisticated and built on distributed architecture, planning the component on as many affected computer systems as possible. The reaction to this way of developing malicious software was imagined of distributed system for their detection, including distributed centralized system (DDS), along with a higher indicator of their stability in relation to the manifestation of malicious software. They are checked by a much higher inherent complexity, large volumes of processed data and calculation, which leads to a loss of productivity of computer system in terms of basic functionality. In order to reduce cost for the operation of DDAs against malicious software without reducing the effectiveness of their work, it's proposed to include external hardware support tools in their composition. In the proposed version, it's implemented as a USB calculation based on microcontroller. Before performing the calculation, the DDS software modular queries the configuration of computer system, and it includes a USB, the request for the exertion in direct not software produced, but to the USB calculator. Hardware support for DDS function allow not only to speed up calculation, increase the effectiveness of DDS decision making, but also to perform other process of ADS or computer system functional in parallel with them. In a functional feature includes a processor device, non-volatile program and data memory, RAM and USB interface controller combined into single circuit by approach buses. The USB interface controlled in use it to ensure data exchange between the USB computer and the host. The basic schema of is a Atmel AT90 USB 1287 microcontroller is a commercial 80 bits smooth microcontroller based on the AVR RISC architecture. To the extension of the most commands in synchronized period, the performance of this microcontroller reached on 1 million operations per second at 1 megahertz clock frequency. Its AVR core is set of 135 instructions that manipulate 832 universal operation registers. This makes it possible to implement a rather complex calculation algorithm of decentralized distributed system in the code of this microcontroller. In addition to producive architecture logic device, the of the microcontroller figure 3 includes the non-volatile programmable flash memory with read-to-write support program memory and RAM. This made possible to implement all modular of the functional schema internally without including additional components in the principal schema. The architecture of the microcontroller includes hardware implementation of USB data transfer interface. Its structure in figure 4, the USB controller contains all the necessary components to connect the USB channel to build dual port random access memory, DPRM. The approach to selection of the component composition of the USB controller made it possible to implement schematic diagram with a minimum number of external elements which determine its compartments. The assembled schema does not require hardware debugging and is ready, for initialization procedure. After passing the hardware reset signal, the microcontroller is set to the initial IDLE start of IDLE. In this mode, the processor core goes into stop mode. The processor core is activated by first interrupt from the USB controller. The USB computer, like an other USB device, support a hot plug-and-play connection with dynamic loading and unloading drivers. After the user inserts a device into a USB port, the host finds the connection ports for newly installed device and loads the appropriate driver. This USB computer is defined in the Windows operation system as device AT90 USB 1287. For this, it is not necessary to use the Atmel Flip installer program or the corresponding version. It must be installed on the computer on which the USB computer will be installed. After completing the sequence of steps described above, the microcontroller device will appear in the system as shown in figure 5. The algorithm of USB computer software are built based on the rule that initiates the launch of its function in the host machine, which the USB computer works. The application software of the USB computer consists of two main modules. The interact throws a shared memory organized as a ring program command buffer signs the computer process performed by the host machine and the USB computer are asynchronous relative to each other. The use of ring buffer. This approach to selection of the component composition of USB controller made it possible to implement schematic diagram with a minimum number of external elements. Make possible to organize the command transmission channel from the host to the USB computer as calculation result with a low cost. The first software model is subroute the processing external interrupt of microcontroller and is responsible for receiving from the host which is under the control of the decentralized distributed system command for performing calculation of security status, storing their result and issuing the upon request of the system component. The algorithm of its work consists in receiving from host machine a sequence of commands of the decentralized distributed system and placing them in the ring program buffer. The algorithm of modulo 2 of USB calculation consists in checking the ring program buffer for the presence of commands from DDS. It's not empty. The modular reads the first command and performs its description. After that, calculation implements the functionality of the command. The DDS command system for combination malicious software for USB computer includes 5 basic commands, car01, car05, and can be expanded. The car01 command is intended for clearing the memory of USB computer, allocated for saving the result of ADS security state calculation. Teams car02 and car05 are appointed to perform calculation of DDS safety states as the first and second stage, respectively. Teams car03 and car04 are assigned to transmit the result of calculation of safety status as the first and second stages, respectively, to the DDS. The car02 team's programmability implements the algorithm for calculating the security states of decentralized distributed system at the first stage according to the formula. The security level of the system, as can be from present formula, depends on number of DDS software modules and the probability of their damage by malicious software when they are in one of the S states. Command car05 is assigned to calculate the security status of the decentralized distributed system at the second stage, and according to the formula with number J in state as I12 spent by the software module with a number in states is number of DDS software module. USB computer command system, where at the DDS is a DDS security level determined at the second stage as DDS software module. Number of DDS software modules is number of stages, and it's a correction of the previous formula. Evaluation of the effectiveness of the use of USB computer DDS. The 2 experiments were conducted to verify the effectiveness of using USB computer as hardware support for the work of the DDS to combat malicious software. Their results are given slide. The first experiment considered in fixing the loading of processing of the computer system during the operation of DDS with the software implementation of calculation operation for determining the state of its security. Its results shown in graph 1. The second experiment consisted in fixing the loading of the processor of the computer system during the operation of DDS using the USB calculator to determine the state of its security. Its result is shown in graph 2. The analysis of result of the first experiment showed that in this case, the workload of central processor increased by 35%. The analysis of result of the second experiment showed that when using USB calculation, the processor load increased by less than 10%, and even the only 1.5 seconds in array of output data is being transferred for calculation. The average load growth does not exceed 1.5%. A compression of results conducted experiments showed that the result support for DDS work allows to reduce the load on the central processor of computer system by more than 30%. The main literature, Savenko as the theory of practices, creating distributed system, detection of malicious offense in local computer network. This dissertation for obtaining the scientific degree and other. Thank you for your attention. Have you any question?
Thank you, Mykola. Colleagues, any questions? Mykola, can you say, please, what is your next research? What your future work will be devoted to?
My next development step is up effectiveness of my microcontroller. With he must be more effectiveness for working, because it's not have another version of microcontroller that can work with malicious software.
Okay, I see. And what kind of malicious can maybe you change some types, or it will be devoted exact that type of malicious you are dealing with? Maybe you add new kind of malicious that will be able to detect it.
It's worms that malware for DDoS attack and other.
Thank you. Okay, colleagues, any more questions, please? No? Okay, so thank you for your fruitful work in this section. Thank all of you. Thank you for presenters, for questions. And now we will have, thank you, Mykola. We will have break. See you. Bye-bye.